pictorials of PXRF. Who's used this before? So a couple people have. Okay, so this is a PXRF instrument. It's one of the more popular ones that folks are using in soil science. It's a Vanta M series made by Olympus. This model was about 40,000 total ish. Okay, so what the principles of PXRF. So what I'm doing is I'm going to be shooting X-rays into a sample. Okay, and then the primary X-rays are going to interact with the elements. Okay, and in the elements we have a nucleus and we're surrounded by electron orbitals, right? Okay, so what that happens, and that's stable as it is, but the X-rays destabilize it. Okay, and what they do is they lose an electron from a lower orbital, and then one from a higher orbital is going to fall down to replace it, to stabilize it. And in doing so, we have an energy imbalance. So then the secondary X-rays are emitted. Okay, and then what we're measuring here in the detector are those secondary X-rays. Okay, and then what we're going to be getting from this instrument is a spectra that looks like that. Okay, and those peaks where they occur correspond to different types of elements, and then the area of the peaks we can use that to approximate the concentrations of the different elements. Okay, so what elements can we do with this, with PXRF? Can we do all of the elements on the periodic table? You can't probably read that periodic table down in the handout there, but the ones that are gray, you can't do. The ones in the middle that are yellow colored and green colored, we can do with pretty high accuracy. So the green colored ones are going to be plus or minus 5 part per million. The orange colored ones are going to be plus or minus about 10 part per million. And as we move towards the edges, we're getting plus or minus more parts per million, and we're getting to a point where we probably shouldn't be doing PXRF for this. So generally the heavier elements and things like lead, arsenic, zinc, cadmium, and iron, which I've given you some data on this, we can do plus or minus 5 to 10 ppm. And it's a pretty decent screening tool for that. And there's been lots of studies that have taken this and then correlated that to more acceptable laboratory methods like ICP or atomic absorption spectroscopy and found pretty tight correlations. Okay, so are there any questions on what this instrument does or how it works?
What kind of error is the issue with using it? User error. What do you got to kind of watch for?
Yep, so let's talk a little bit about that, and while I'm doing that, I'm going to fire it up. So and maybe we can frame it as like pros and cons of an instrument like this. Okay, so what are some disadvantages? Let's start with that. So you do have to consider soil texture differences. You could have some interference there. You need to consider maybe moisture differences. Okay, you can't do all of the elements, and you're not going to be able to get the. One second. Make sure it's seen to it. Oh, we should put a battery in it. So user, speaking of user, it helps if you put a battery in it. Yeah?
That's the first rule. Turn it on.
That's the first rule.
Brian, can you talk about like variability, spatial variability?
Yep. In what context? What do you mean?
Like just the small window of view for the sample.
So it's not on right now, so I'm okay holding this up, but this is an X-ray source right here, and it's going to measure in this little window right here. Okay, so that I look at that as an advantage and disadvantage, right? I'm getting this little snapshot, right? But when we do chemical analysis in laboratories, what do? We take a sample from a horizon, we take it to a laboratory, dry it, we grind it, we process it, and we might do a little pinch of soil, depending on what we're running, right? So this window is actually giving us a pretty good look at, and we can do multiple readings very quickly. The way I have it set up right now, this instrument is going to run three beams, 20 seconds each, and I can get my readings in 1 minute. I can change that. So I can do some really fast readings. And I can capture some of that variability, right?
And it's in situ too, so it's not that grind and reprocess.
Okay, so some of the advantage in situ, I can measure this right in the field, right? What other advantages do you all think about an instrument like this? Quick. It's relatively cheap once I purchase the instrument, right? Okay, once you purchase it. But then you can, and we talked about this in the urban soils group yesterday. In urban soils, we're very concerned with contaminants, And a lot of you agency folks don't have abilities to do stuff like this, but many universities are picking these up now, and I encourage you to create some partnerships with those universities, and they can help you screen for it. I mean, this one we bought was through a USDA partnership grant. And then
Brian, what's the cost?
it's about 40,000 or so.
Thanks.
And is there consistency in product? I mean,
Oh yeah, the different instruments. Somewhat. I'm not the best person to answer that one because it's the only one I've used. But
They
this
all
from
have
talk-
kind of different calibration curves and different, like slightly different approaches, but there's fairly good consistency.
Are you gonna get a result like you can interpret on the screen, or do you have to do it? Garrett
Yeah.
showed us yesterday.
No,
we
so that's one of the big advantages. So what Garrett was talking about, MIR,
Yeah.
and that's another tool that we can use to predict carbon. So we
Yeah.
can't do carbon with this. Although there's lots of research out there now, well not lots, there's research out there that are starting to develop predictive models. And we've used this in addition to the MIR and without the MIR to do things like predicting texture, predicting organic carbon, predicting pH, predicting electrical conductivity. So I look at that as an advantage. We can develop, pedal transfer functions based on this other data. Yep. Okay. But yeah, I get instantaneous results. I don't have to use some fancy software.
Yeah, sweet.
Okay, I can see it right on the screen. I can hook it up to a laptop, and when we run in the lab, we do that. And we have a confined system that keeps all the x-rays in place as well too.
And I think I've heard you can also, like, you can have it in the bag and
Yep.
do it, so you don't have to worry about getting the machine dirty
Yep, that's
or contaminant getting on something or
Sure.
everywhere else.
in field. So I'll do a lot of folks will call me up and think I have contaminated soil in my yard, and I'll come out to their yard and bring this out there, and I'll shoot it straight down right on the sample right there. And we have a little aperture right there that's got a little film on there, and sometimes I'll put like a little plastic parafilm, or not parafilm, like a plastic wrap on top of it to protect it. These samples right here, since I figured they were going to be really high concentration, I collected them in bags and scanned them in bags just to limit the contact with that. So that's what all these samples are over here. And the data that I'll talk about in a little bit, so I'll provide it to you in your handout for these different samples.
Have you been seeing differences in the pit versus taking it to the lab and running that?
Yep, so the question was, have you seen differences in the pit versus the lab? So we did a study on that, and what we did is we had a bunch of pits like this, and we scanned a whole bunch of horizons, and then we took those samples, and a typical laboratory sampling sort of protocol is you collect them, you homogenize them, you get out the coarse fragments, you dry them, we actually ground them a little bit further, and then we ran this instrument with it to see if there was differences. And there are for some elements. So things like lead, we saw really strong correlation and a pretty tight one-to-one relationship. We didn't lose much information when we go to the lab, but other elements, especially some of the lighter ones, we lose a lot more information. Okay.
Is that
Are
because
those
of where
literal-
the elements are in, like is that like a macro versus micro pedology type thing, where you're getting, it's concentrating on like the pet surfaces and whatnot, like moving?
So we thought about that, but then some of the things that we're getting disagreement with, we had them in really high concentrations. Okay, so I think it comes back to like the instrument itself, and moisture interference is the big one, I think.
Okay.
Yeah, that was my question. You see more of a moisture interference
Yeah.
with the lighter
Yep,
elements than
yep,
with the heavier?
that's what we think, because something like sodium, it'll give you some
Yeah.
results like that, right?
What kind of agreements do you, or